point-slope form. This is the formula for a point-slope form of the equation of a line, where x1 is the x of the given point, and y1 is the y of the given point, and of course m is the slope. So we're going to plug that into this particular formula and see what it gets us. Y minus equals m times x minus. And in the spot for y1, we're going to put the y from the given point. In the spot for x1, we're going to put x for the given point. And in the spot for m, we're going to put the slope. So this is the equation of the line in point-slope form, but it's often far more useful to have it in slope-intercept form. So we're going to put this into slope-intercept form. So what we have now is y minus 4 equals 1/2. And if we distribute that, we get 1/2 x minus 2. Then if we add 4 to both sides, that gives us y equals 1/2 x plus 2, the equation of the line in slope-intercept form. Now let's take a look and actually graph this line. First, we know it goes through the point 4, 4, because we're told that here, and it's got a slope of 1/2, up 1 over 2. So if we graph the same line using the equation in slope-intercept form that we pulled out of this after that work, we should get a line that goes directly through those 2 points. Let's see what happens. The y-intercept is 2. The slope is 1/2, up 1 over 2. Or, remember, it's -1, -2. And we find exactly what we were looking for. We find a line with a slope of 1/2 that goes through those points. Now sometimes, instead of having the slope and a point, you're given 2 points and you have to find the equation of the line. Well, we still use point-slope form, but the first step is to find the slope. Now if you remember, the equation for the slope given 2 points is m equals y2 minus y1 over x2 minus x1, where this is x1, y1, x2, y2. So that would equal -5 minus 4 over 4 minus -2. Add the opposite. That gives us -9 over, add the opposite, 6. So m equals, reducing that, -3 over 2. So we have the slope. Now we need to find the equation, and we're going to use point-slope formula right up here. But we have 2 points. It really doesn't matter which one we use unless one looks easier than the other. Maybe it involves 0, or for some other reason one looks easier than the other. For this, it doesn't seem to matter. So I'm going to use this point. So that's going to give us y minus y1 equals the slope, which we found is -3 over 2, times x minus x1, -2. Now, minus a negative, we can do that. So this would be the equation of the line. However, often it's convenient to have it in slope-intercept form. So I'm going to do a little conversion. Y minus 4 equals -3 over 2x plus, that's going to give us -6 over 2. But of course that reduces. If we reduce 2 goes into that once, 2 goes into that 3 times. So we now have a 3. If I add 4 to both sides, that gives me y equals negative 3 over 2x minus 3 plus 4 is plus 1. So that's the equation of the line in slope-intercept form, I hope. Now let's go back to what we were originally given. We were originally given 2 points. Negative 2, 4. 4, negative 5. Now, when we find the equation of the line and graph it, it had better go through those 2 points, because that's what we were looking for, is the equation of the line that does go through those 2 points. So we have the equation in slope-intercept form. Let's graph it. The y-intercept is 1. The slope is negative 3 over 2. So that's negative 1, 2, 3 over 2. Negative 1, 2, 3 over 2. Certainly goes through that point. Or it could also be 3 over negative 2. So that's 1, 2, 3. And it certainly does go through those points exactly as it should. So to recap, we started with 2 points. We could have simply drawn the line through those 2 points, but then we wouldn't have the equation. So we calculated the slope, got negative 3 over 2. So now we know a point and an extra point that we're choosing to ignore, and the slope, so we can use the point-slope form of the equation of a line. We converted that into slope-intercept form because realistically, when you move on into more advanced math, especially in calculus, you're going to want things in what's called function form, which is what this is. So we graphed that line and found out, sure enough, it goes directly through the 2 points that we were looking for a line to go through.